Hello everyone and welcome to the Chandara Academy. Today we are going to correct an exercise about complex numbers. So first of all, just a quick reminder of the three forms of a complex number. We have the algebraic form, the trigonometric form and the exponential form. The first form, the algebraic form, is written like that. Z equals A plus IB. A is the real part of Z. And B is the imaginary part of Z. If you represent Z on a graph, you have here the real part of Z and here the imaginary part of Z. Then you have the trigonometric form. With this form, you can see the modulus and the argument of Z. Or is the modulus of Z, and theta is the argument of Z. If you represent it on a graph, you have the modulus of Z here and the argument of Z here. Then you have the exponential form. It's pretty much the same thing as the trigonometric form because you have the modulus of Z here and the argument of Z here. You can go from the trigonometric form to the exponential form by noticing that exponential I theta equals cos theta plus I sin theta. So now that we have in mind the three forms of a complex number, we can correct the first question. The first question is write Z1 in a trigonometric form. We have Z1 equals 1 plus I, and we want to write it in trigonometric form. So in the form Z1 equals R cos theta plus I sin theta, with R equals the modulus of Z1 and theta equals the argument of Z1. Okay, and here we have Z1 equals A plus IB, with A equals 1 and B equals 1. So we can first of all calculate the modulus of Z1 by writing that the modulus of Z1 equals the square root of A squared plus B squared. So it's equal to 1 square plus 1 square. It's equal to the square root of 1 plus 1. And then we have that the modulus of Z1 equals the square root of 2. Okay. Now that we have this result, we can now calculate the argument of Z1. Okay, we know that Z1 equals R cos theta plus I sin theta. But R, you remember that R, it's the modulus of Z1. So if we divide Z1 by the modulus of Z1, we have cos theta plus I sin theta. So now we can calculate Z1 divided by the modulus of Z1 because we know Z1. Z1 it's 1 plus I. And now we know the modulus of Z1. It's square root of 2. And this we can write 1 divided by the square root of 2 plus I multiplied by 1 divided by the square root of 2. And here, because it equals cos theta plus I sin theta, here you can recognize that this, the real part is cos theta, and this, the imaginary part, it's sin theta. Then you can write that cos theta equals 1 divided by the square root of 2. And then sin theta equals 1 divided by the square root of 2. And now you can write that the tangent of theta, that is equal to the sinus of theta divided by the cosinus of theta, equals 1 divided by the square root of 2 divided by 1 divided by the square root of 2 equals 1. And now you can write that theta equals the arc tangent of 1 and then you find that theta equals pi divided by 4. So you found the modulus and the argument of z. Now you can write the trigonometric form of z1. So z1 equals r cosine theta plus I sinus theta. And because we know now that r equals the square root of 2 and theta equals pi divided by 4, we can write that z1 equals square root of 2 multiplied by cosinus pi divided by 4 plus I sin pi divided by 4. And we have put it z1 in trigonometric form. Then the question 2 is calculate z2 power 16 with z2 equals the square root of 2 plus z1. Then we have z2 equals the square root of 2 plus 1 plus I. First of all, we will calculate, as before, the modulus of z2. And we know that the modulus of z2 equals a square plus b square under square root, with here we recognize the a, and here we recognize the b. b equals 1, and a equals the square root of 2 plus 1. Okay, so here we have the square root of 2 plus 1 square plus 1 square. It's equal the root of 2 plus 2 root 2 plus 1 plus 1. And then we found that the modulus of z2 equals the square root of 4 plus 2 root 2. Then we will calculate the argument of z2. So same as before, we know that z2 can be written in a form like that, or multiplied by cos theta plus I sin theta, with r that equals the modulus of z2 and theta that is the argument of z2. So we will divide here. We will divide z2 by r so that we are able to get the value of cos theta and sin theta. So we do z2 divided by the argument of z2, and to do this we take the value of z2 that we have here. Okay, so z2 it's square root of 2 plus 1 plus I, and we divide by the value of the modulus of z2 that we found here. So we divide by the square root of 4 plus 2 root 2. And then we will separate the real and imaginary part. So we have square root of 2 plus 1 divided by root 4 plus 2 root 2 plus I multiplied by 1 over root of 4 plus 2 root 2. And here we can see that because we had this formula, we have also that z2 divided by the modulus of Z2 equals cos theta plus I sin theta, because of this formula here. Then we can recognize here cos theta, and here the imaginary part is sin theta. So now we know the values of cos theta and sin theta. So we have cos theta equals root 2 plus 1 over root 4 plus 2 root 2, and sin theta equals 1 over 4 plus 2 root 2. And then, as before, we write the tangent of theta, that is equals to sin theta over cos theta, and it's equals, because this and this will eliminate, we will just have 1 over root 2 plus 1. And then, because we have tan theta that equals to 1 over root 2 plus 1, we have also that theta equals arc tangent of 1 over root 2 plus 1. And finally, we use the calculator to calculate this, and we found that theta equals pi over 8. Now we have the modulus and the argument of Z2. In an exponential form, we have then V2 equals, here we have the argument of Z2. It's square root of 4 plus 2 root 2 exponential I, and here we have the argument of Z2, pi divided by 8. And thanks to this, we are able to put Z2 power 16 as it is demanded by the question. So power 16, we put the argument power 16 and the exponential power 16 also. And here it's equals to exponential I pi over 8 multiplied by 16. This equals exponential I pi multiplied by 16 divided by 8, and this, it's 2. So it equals exponential I 2 pi. And this, we know that it equals 1. So everything here equals 1. Then we have Z2 power 16, that it equals the square root of 4 plus 2 square root of 2 power 16 multiplied by 1. And then it equals to this only. And then you use your calculator to calculate this, and you find that Z2 power 16 equals approximately 4.7 multiplied by 10 power 6. So that's the result, and we finished the exercise. Thank you girls, I hope you enjoyed this video and that it was helpful, and see you next time!